Your system is not expensive because your vendor is expensive. It is expensive because your architecture allows expensive behavior to emerge. And most teams only discover that after the bill arrives. That is exactly why FinOps feels useful. Because by the time cost becomes visible, architecture has already disappeared behind dashboards, tagging strategies, and monthly reports. So the problem gets reframed, not as a design problem, as a tracking problem. We need better tagging, better allocation, better alerts. But none of those things control the behavior creating the spend. They only improve your description of it. Because cost is not created in the finance layer. It is created in the interaction layer. It is created when your architecture decides how many times something is allowed to run, how far something can fan out, how many services participate in one outcome, how failure is handled, how much duplicated work is tolerated. That is where cost comes from. Take a very normal system, API gateway in front, Lambda behind it, events for decoupling, SQS for buffering, step functions for orchestration, DynamoDB for state. It looks efficient. And at low volume, it often is. But cheap at low volume is not proof of a good architecture. It is just a system that hasn't started interacting yet. Now the system is under pressure. A request enters. It triggers a Lambda. That Lambda writes state, emits an event, and invokes downstream reactions. One consumer enriches data. Another triggers a workflow. That workflow emits new events. Those events trigger more processing. Now add retries, because something fails. Now add duplicates, because delivery is at least once. Now add timeouts, because something is slower than expected. Now add logging for every step, tracing for every path, metrics for every component. Nothing here is wrong. But the system is no longer linear. It is multiplicative. One business action is no longer one flow. It is a network of interactions. And that is where cost comes from. Not from compute, from how many times the system is allowed to do work. Two systems can handle the same user traffic and produce completely different bills because one translates intent into a bounded flow. The other translates it into a cascade. FinOps can tell you where money is spent. It cannot tell you why the system needed to spend it that way. It will show you Lambda invocations increased, data transfer is rising, logging costs are growing, queues are processing more messages. All correct. But none of it answers the only question that matters. Why did one action turn into so many? That question lives in architecture. And this is where most systems drift, because modern patterns optimize for local goals, while hiding system-wide consequences. Microservices optimize for team autonomy. Event-driven systems optimize for decoupling in time. Serverless optimizes for operational simplicity. Managed services optimize for speed. All of these reduce friction, and friction is what used to limit interaction. When you remove friction, you don't just make systems easier to build. You make them easier to expand, more services get added, more consumers subscribe, more retries are configured, more flows are triggered, and because each step is individually cheap, the total system becomes expensive. Take retries. A retry is not just a safety mechanism, it is a decision. It says when something is uncertain, create more work. If the downstream system is already under pressure, retries don't fix the system. They increase demand exactly where it is weakest. Now your real traffic is no longer user traffic. It is user requests plus retries, plus duplicate processing, plus compensating actions, plus everything those trigger. And because cloud cost is usage-based, the system becomes more expensive precisely when it becomes less stable. That is not a financial issue. That is a feedback loop. The same applies to fan-out. One event becomes many consumers. Each consumer feels cheap to add, but every new consumer adds more execution, more failure paths, more logs, more downstream calls, more coordination. The producer stays simple. The system becomes expensive, and nobody owns the total interaction. That is why architecture reviews often miss this. Because they validate components, not behavior. They ask, can this service scale? Can this queue handle throughput? Can this function complete on time? But they don't ask, how many times can this system act on one request? What is the worst-case interaction count? What happens when failure occurs repeatedly? Where does the system stop? If those questions are unanswered, cost is already out of control. So how should this have been designed? Not by making components scalable, by making interactions bounded. You need to define how many downstream steps are allowed, where retries are acceptable. where idempotency is guaranteed, where duplication is tolerated, where interaction must stop. If the system is allowed to expand without limits, it will. And that expansion is what you pay for. Most systems are only designed for success paths. Failure paths are left to defaults. Defaults are decisions you didn't make, but your system still executes them. Retries, timeouts, redrives, logging levels. But defaults are not architecture. They are outsourced decisions. And when enough of those decisions combine, expensive behavior emerges that nobody explicitly designed. Fixing this is not a cost optimization exercise. It is an architectural one. You need to find where the system creates unnecessary work, where one action becomes too many, where failure creates amplification, where fan-out has no owner, where convenience patterns became expensive at scale, where no one can change the system quickly because ownership is fragmented. Because some systems are expensive, not just because of how they run, but because of how slowly they can be corrected. That is the real tension. Autonomy versus coordination, throughput versus control, flexibility versus predictability, speed versus understanding. You don't remove these, you decide where to absorb them. If you optimize for autonomy, you often pay in duplication and cost opacity. If you optimize for flexibility, you allow more behavior than needed. If you optimize for speed, you create systems that are fast to extend and slow to understand. And systems that are hard to understand are expensive to operate. So the role of the architect changes, not how do we reduce cost, but what is this system allowed to do? How many times can it retry? How far can it expand? How many dependencies are required? Where does interaction stop? Because if you don't define that, there is no limit. And a system without limits does not become scalable. It becomes expensive. Architecture is not what you deploy. It is what your system is allowed to become over time. FinOps doesn't control cost. It observes it. And if that's where you're trying to fix it, your architecture already decided you can't.